When it comes to obtaining the factors of any number, the another useful concept we must learn is how to obtain the prime factors, okay? And the technique is called prime factorization, okay? So what exactly is that? Let us take a look at this number 24, okay? So now I ask you, help me find all the factors of this number 24. You will say that we'll begin with 1 and the next factor is 2 because 24 can be completely divided with 2, and so is 3, and then there is 4, and so on. The next number I find is 6, and 8 is also a factor of 24, right? And the next higher number will be 12, and then finally you will stop at 24, okay? So 24 is the largest factor of this number 24, right? So what you notice here is that even though we are finding all of these factors, but some factors seem like repeating themselves, because I can say that 8 is a product of 4 and 2, right? And then there is a factor 6. I can say that 6 can be obtained as a product of 2 and 3, right? So it appears that there is some repeat in the numbers here, right? So that is why sometimes it is important for us to understand how to obtain factors of a number such that they are irreducible and they cannot be divided any further, right? And that is called prime factorization, okay? And how exactly we obtain it? Now there are essentially two different ways you can obtain prime factorization, and one of those is called the factor tree method. Now what this method does is that, let's take the number 24, the same number that we have these factors, right? And we will start dividing this number with the lowest prime number first, okay? And what is the lowest prime number? We see that 2 is our lowest prime number, and 2 can divide 24 evenly, right? So we'll take that this is my first divisor, 2, and it divides 24, we obtain 12. Then I take this number 12 and I repeat myself, and I find the lowest prime number that can divide 12. I find that that number is 2 again, right? And then when I divide 12 with 2, I get 6, right? Then I repeat one more time. I continue this until I reach a point when we cannot divide any further, right? In this case, we have the number 6. 6 can be divided with 2, we obtain 3, and 3 is a prime number again, right? It cannot be divided any further. So we stop here. Now that's how you obtain your prime factors. Now all of these divisors that we have obtained, the 3 2's and then there is a 3, these are the prime numbers, or in other words, these are the prime factors of 24. So when you have to write 24 as a product of these prime numbers, you will say that 24 is equal to 2 times 2 times 2 and 3. And these are called the prime factors. And this technique is called prime factorization, right? Now let us take a look at what is our second method. Now this is essentially the same as the factor tree method. It is just a different way of representing your division, okay? So in this case, let me pick a different number to give the example of short division method, and I take the number 36. What I do is I'll make a nice table here, and I start once again with the lowest prime number, and I'm looking for a number such that it can divide completely, but this number has to be a prime number, okay? That is the condition, all right? So I divide 36 with the lowest prime number, and that happens to be 2, and I get 18. So that is my step 1, okay? Then this 18, it comes back in the dividend area, right? And then I repeat myself once again. I find another lowest prime number so that I can divide 18 completely, right? So 18 can be divided with 2 again. I get 9, and this completes step 2. Then I take 9, take it back to the dividend area, right? And I divide with the lowest prime number, and that happens to be 3. So 3 times 3 is 9, and this completes our step 3. So finally, I have obtained 3 here. I get 3 back in the dividend area, and of course, 3 is divisible by 3, which is a prime number. You get 1, and then finally you stop. You stop when you have obtained 1 here, all right? Now what you have is a nice list of all of these divisors, and you can say that 36 can be written as a product of all of these divisors, right? 2 times 2 times 3 times 3. And this is how you obtain the prime factors of this number 36 using the short division method. Okay, so you see that conceptually the factor tree method and the short division method, they both are essentially the same, because at each step along the way you are looking at a prime number so that you can divide your given number. Okay, and finally you stop when you cannot divide any further, right? So this is what is known as prime factorization, and this is the technique that we have discussed. And this is going to be used extensively when you learn about the least common multiple and the greatest common factor. Okay, so with that, let us pause here and go to the next tutorial about highest common factor and the least common multiple.